Okay, my friends, get ready for some fun. This is the Commonwealth Club, and this is Brian Hackney. I believe it was CBS News. Avi Loeb is from Harvard, and this is a Mau Mau. And this is, like I say, the Commonwealth Club of California. And here's what it says. Are we alone? Avi Loeb, Harvard's top astronomer, doesn't think so. He believes that, hold on a second. He believes our solar system was recently visited by advanced alien technology from a distant star in 2017. Scientists in Hawaii observed an object soaring through the sky, moving too fast along a strange orbit for Loeb to conclude it was a regular asteroid. Instead, he suggested the object could be a piece of advanced technology created by a distant alien civilization. Now, this just came out in March of 2022. Now, I have some very solid evidence to present that this is actually biology. So let's take a look. I gotta tell you something kind of funny. This guy sent me this Cosmos episode with Carl Sagan, and he was talking about Earth being virtually like a living creature, which it is, or it was, because I don't know, it's in trouble now. But then they dubbed in everywhere he would talk about it, Earth, they would say meat, and they call this the meat planet. But Carl Sagan is going through a personal voyage of how he discovered that the planet is, and the whole cosmos is literally from living creatures. So I feel like I've been peer-reviewed by Carl Sagan. I agree, Carl. Living creatures, buddy. Rest in peace. Okay, this is the Oumuamua. It says it's a visitor from another star system. That was the news a few days ago. This was in 2017. This article was written in 2019, when researchers discovered an enigmatic cigar-shaped object screaming away from the solar system at 57,000 miles an hour. The entity was moving too fast to have originated from our own solar system, traveling on a U-shaped hyperbolic orbit that took it around the sun and sent it back out into interstellar space. Now, I don't know about any of that stuff, but I do know what that is, and I'm going to show you what it is right now. Okay, let's just start by saying that this to the right is Oumuamua, which is a finger. This is the bony structure of the finger. Oumuamua has much more on it, which I will show you in a minute, but let's look at where the emplacements are first. Now, this is the first segment here, which is the apical tuft. You see that little round spot has all that stuff on it, and this is actually the grip skin has started to erode away, but you can see there's a layer. We'll probably look at it a little closer. This is the apical tuft, which is right here. All of these little tendon balls invest into those little holes, and then there's a whole bunch of little holes right below it where more tendons invest. Hold on one second. Okay, what I'm going to show you is some anatomical stuff. We're going to start with deep down inside where the bones are, where the joints are, and where the apical tuft is. And then we're going to look at the tendons and so forth, and where the knuckles are in a second. All right, this is the tip of the finger. There's flesh on here, and then there's skin, the grip skin, the friction skin, which is the heavy skin that coats and keeps you protected so you can do a lot of work with your fingers. And it's on your palms of your hands and your feet and toes and so forth. Now, there's a bunch of tendons that run from here. You see those little tiny holes there? That's this right here, this joint. A whole bunch of tiny holes over this side. And they have to pull and pull. Then there's a tendon that runs up right to here so that you can make your fingers do these kind of things. This is the actual joint right here, the same as that. This is the investment right here. This is the investment right here. This is the apical tuft, which is this little piece right up here. That's the tip of the finger. There's flesh under here, and that is the heavy-duty skin. And let me show you another shot which will show you a little more about Amaro Maro, which is this particular tendon that runs down, which is on the inside, this side of your finger. All right, this is at the bottom of the finger facing this way. All right, this is the palm of the hand, and basically this is the tendon that we're looking at up here, right there. That's the tendon. And then there's another one, and of course it invests down here too, all these balls here and these balls here. This is way down right at the knuckle. We're going to come up and look at this very closely in the computer and lock in on it. But you can see it is a finger. It is completely, and I had anatomists look at it, and they say, yeah, there's no question. It looks exactly like a finger. They're not going to say it's a finger, but they say the anatomy is identical, no difference. As a matter of fact, one of them told me specifically, it's the fingeriest looking finger I have ever seen. All right, we're going to go over to the anatomical again, but I want you to look at this. You see this little white strip down here? And it's white right down here, and then, like I say, that's where all those little balls attach. This is the apical tuft, and that's the grip skin that's on the tip of the finger. That's your knuckle, your joint right there. And then it comes down to this bone down here, which is right above this. It's snapped off of that bone. Boom. That's the tendons that run up. I'll show you in a second. On the other side, they run up the finger. On this side, you also have tendons. And I will show you both of those right now. That black spot is where the vein runs to bring the blood back to the heart. This little spot right over here, which you don't see anything because red blood blows out, so he ends up seeing like white spots. That runs down, would have brought the blood down, and then it come back this way. This is the tendons again, and that's really just hanging right over the edge of your knuckle right there. Now, don't forget, there's going to be tendons on the other side coming up, and these are the tendons on this side. Let's go back to the anatomical again. Okay, let's start out with the part you can't see. This is we're looking at the palm. This is the top, the back. Now, these tendons run down, but what I want you to see is these are the knuckles right there. Those tendons run right over your knuckles. And that's what we see hanging over the back, and these are two tendon straps that run down here, very heavy duty ones. Well, it's actually three, but that's the top of your finger, and they hang off the back. Now, what about the bottom? This is the bottom right here. All right, now, these are the tendons that run down, and they attach, it's hard to see because they're down inside deeper. This is the deeper look here. Now, they attach. You see how they're attached to this little spot right here? And they attach, they show them, it's getting deeper and deeper and deeper and deeper in. This is the attachments that we're seeing. But we're also seeing this tendon coming down to those attachments. That's a Amaro. Okay, remember I talked about that skin peeling off of Amaro at the very tip. It's called grip skin or friction skin. It's real tough keratinized skin. Right there, you can just peel that right off because it's just like it shows on that asteroid Amaro. See, I have evidence coming out of my ears. That's a giant fingertip. It's 3 feet long. Mud fossilization in the hard mud fossil process. There's one that's under the mud and stays under the mud. It's more of a mud fossil. These are turned into really hard stone. This is the fingernail. That's the little pad that bumps up from bone to bone so they don't scrub. Vein and artery. I broke this pad off right here, and it just popped right off because it's just basically like glued on. And I'll show you what it looks like, and it still had the fingerprints on it. Where is it? Here it is right here. You see that? This is the kind of skin. It's called keratinized cells. There's two different things that your body produces to protect you. Keratinized is like the other style, which is oh boy, I haven't I'm even thinking about now. Collagens. So you got keragens and keratin, and you got collagen. Collagen is a little more rubbery. This stuff turns into sandy, really gritty, heavy-duty stuff. Really tough stuff. The other type, collagen, totally different, turns into a soft, almost slimy. Now, but this stuff is tough. That's why it's on. That's why it just peels right off. So, and this has the fingerprints on it. And that was DNA tested. Well, not all my stuff, but I had 3 things DNA tested. They all came back human. Because the anatomy is there. It's absolutely certain. I mean, if you can't tell that's a fingerprint, I don't know where you're from. Okay, so I feel 100% validated by Carl Sagan. It's exactly what I've been saying. There's not a thing in space or on Earth that is not biological. And these are things that I had DNA tested. The lung, I had a couple of giant mud fossils DNA tested. That big finger thing I showed you. And then the palm of the hand, that's like 4 feet wide. This other fingertip is 3 feet long. Now, I extracted the samples. I didn't send them these giant fingertips. I can hardly even move it. As a matter of fact, I damaged my shoulder trying to move it around. It must weigh 400 pounds. And it's 3 feet long. Probably more than that. I have no idea. But anyway, they all went in. The negative controls were negative, and they all went in for this DNA sampling, looking for certain markers in the mitochondrial DNA, and if they were present, it proved that they were human. And so what happened was they submitted these sequences, and excellent quality, you see this? Excellent quality DNA was obtained for that big, huge thumb or fingertip, whatever it was, and the lung. The other one, the mud one, the hand, was a little less because it was buried in the mud, more fluids falling through it. Once they sealed, and they were above ground and dried up, boy, I tell you, they turn hard. But the blood is still inside of them. I mean, the rocks are... You want to see a rock? I'll show you a heart that broke open, and the blood just basically poured out of it. Phil Harris had it. Now, these are the regions, and they were 100% there, no question whatsoever. And they stand behind a test. They just want you to know that I was the one that submitted the samples. I didn't submit like the rocks for them to extract from. I did the extraction, and I did it very well. I know how to do it, and it's very, very simple. And there's a ton of blood in these things. And this was a very sophisticated test. And that goes back to 2015. Okay, just as Carl Sagan did that video, and I don't believe they let him put it up because I don't think it was ever published. Now, I did publish this. It's 99 cents. It's on Amazon, and it's Mud Fossils, Velikovsky, Mines in Collision, because he had worlds in collision. Well, what caused minds in collision? They're still colliding minds today. They cannot accept reality in the scholarly realm. It's just too ingrained in indoctrination and realizing that they will be destroyed. And I'm sure that's why you never heard this from Carl Sagan before. It sounded to me like this was he said, my life's voyage. So I think this was the end of his voyage. He was able to say these things. Okay, my friends, I guess I'm just going to take it one step past Avi Loeb and Carl Sagan and say that yes, the entire universe it appears to me, biology, and the gods appear to me to be as advertised in the ancient Greek myths. And I think I have presented some very, very solid evidence to support my arguments. So I would like to have engagement with Avi Loeb or anybody. Carl Sagan's dead now, so that's not going to happen. But his statements were extremely obvious, and him saying that it was stolen by corrupt politicians, and also saying that it was his life's journey. And it sounded to me like, he figured out things that he didn't realize in the beginning. And that's what happens. I didn't realize all this stuff long ago. You grow if you're allowed to grow. If you're outside the academic system, you can. And I think Carl Sagan was not allowed to grow, and probably knew these things long before the statements he made. And that I don't think was ever broadcast, or that I know of. So we're going to leave it at this. If somebody wants to contact me about maybe somebody important I need to be able to get this message out, somebody that has a big audience, and it would be nice to have somebody, like from CBS News, Brian Hackney, somebody there, Avi Loeb. Anyway, we need discussion, we need Zoom meetings, we need debate. And I have the evidence. I'm not joking about the things I'm presenting. And I even have new species. We call these no-toes. And I have lots of them, not just one. And they have a tibia and a fibula, the same as us. The fibula just falls off. But they have an arch in their foot and everything. They just don't have any bones inside. They have springs. And a little pin that holds the springs in. Anyway, we got a lot to talk about if we can get some discussion going. So that's all I'm asking for. I think I've made a very, very solid case, and I now feel that I am peer-reviewed as far as everything that I have said. Virtually everything I've said now has been peer-reviewed, and even the physics. They say, wow, we were just surprised that the proton is flexible. All right, they always thought it was one big solid chunk like this. And I said, no, it's made of all the tiny little dipoles like this. And at a certain quantity, at a period, they call it, which is 1836, it locks in pretty solid. However, you put it in a magnetic field, it'll do this. Now they just realized that. And I said, wow. That changes everything, and yes, it does. And we showed all those particles, and we showed them actually dividing, and I think we might even be able to give free energy, if I could be spoken about that. When you're outside the system, and you're bucking the system, man, you just can't move it. That's what I have found. At all of these fancy accelerator places, they think I'm a tinfoil hat guy, and have said as much. These are the particles that CERN and Fermilab have seen, the smallest. That is a muon neutrino, that's an electron neutrino. That's squishy, that's fixed. Exactly what they say in this article. Those are the particles. And we see them in photons of light. We use light instead of protons to create the particles. They're smashing things and just digging through debris. And they find these tiny particles, and they know what they are. And I can show them to you right here. Here they are. And the reason we can see them is because we accelerated the light using a Venturi. And I explain all of this, and I understand the reason. And we get sterile muons once we break these particles apart, which is called fission and fusion. All right, the particles were still together here, and now they break apart right here. And now all you got, the little black goes around and the white squirts through, and it recombines here, fusion. And here is the exploded of that right there, which is just what they say, muon and electron neutrino tied together, which is the white and the black ball. When it hits here, they fall apart into Cherenkov radiation, which is muons and electron showers. That's exactly what you see. And then they come back together over here. And I mean, I'm sure this one doesn't jump ahead and get over to here. So there's got to be extra black ones over here. That's my take on this. Now that is CERN or Fermilab, that's one of their drawings, not mine. This is our actual work. But this is that particle accelerating until it hits the Venturi, then exploding into bits and pieces, and there they are. If we could harvest that white spritz right there, that is supposedly 207 times more energy. When you can divide these two particles, and you should be able to get 207 times at least more energy back, which I could see it. There's almost no energy here. When you see something exploding like that, that's almost like well, it is. It's literally a subatomic explosion. When you divide particles, it's fission. When you put them back together, it's fusion. When you explode an atomic bomb, you're exploding atoms, big chunks. You're throwing chunks like this off, flying. We're shooting the tiniest particles that exist, and then they come back together instantaneously. So these are flying for miles at a time. Ours are instantaneously fused back together. No danger here. And once you build this device, if you build it correctly, and the things are on the shelf right now. There's lasers and there's receivers on the shelf right this minute, and then there's harvesters and collectors and sorters and batteries, and everything's going electric, and that's all this is electricity. So anyway, this is my issue right now. I need somebody to help and somebody to engage with this. So hopefully that'll happen. All right, I love you all, but I do feel now that I have been peer reviewed by Carl Sagan. Thank you, Carl. Rest in peace, brother.